Hello. Well, it's been nearly a year since I last uploaded any video at all to YouTube. In particular, I think it was last June or July when I uploaded a mathematics video. Um, one of the last videos, and it might have been the last one, was a solution of a Riccati equation. So we'll just write that down because we're going to have a look at another one of these types of non-linear ordinary differential equation. So um, let me just get black ink there. So Riccati equations are a type or types. I'll put type of non-linear ODEs. So a type of non-linear ODE. All right, and they usually take the form of dy by dx plus a of x. That's just some function of x is a of x. We multiply that by y squared plus another function of x, b of x, times y, plus another function of x, which we'll call c of x. And that's usually equal to 0. So this is a type of equation with which we are dealing. We'll call that equation 1. Now, I want to give you an actual example of a Riccati equation and show you how to solve it, basically, in order that you might develop techniques to solve other types of Riccati equations, or even just general non-linear equations. So what we're going to do is we're going to look at an example, and the example is to solve. I'll write it here so that we're saving space. So dy by dx, so we're solving dy by dx plus y squared plus xy minus 1 equal to 0. And we'll call that equation 2. Note here, I'll write this in green for now. We see that a of x, we could have just called it a really, but a is a function of x. So a of x is equal to 1. B of x is equal to x, and c of x is equal to 1. Now I'll just go over that again. So basically, if we change to red here, a of x is 1, so that's this coefficient here. B of x, which is x, is just this term here. And c of x equal to 1 is, in actual fact, it's minus 1, isn't it? So we should have a minus sign there. Is that term there, minus 1? Right. At the moment, we don't desperately need this information that I'm underlining here. But we're going to simplify equation 2 very, very slightly, not much, but very slightly, with regards to putting it into another form. that hopefully will help us to find a first simple trivial solution to equation 2. So let's go on to the next page and write down the equation once again. So we've got dy by dx plus y squared. Let me just write that a little more solidly. Y squared plus xy minus 1 equal to 0. Now, if we put a bracket, I'm going to do square brackets here, round this term here. We've got it in a particular form, but I'll put a 1 outside the bracket. You don't have to put the number 1 or the coefficient of 1 there, but it helps in this particular case because what we're going to say is this equation, where were we? We're on the previous page there, so we call this equation 3. So let's just erase this here. So we'll write equation 3 is of the form, and I'll write the ODE here to save space. So we've got dy by dx plus y squared plus g of x times, in brackets, xy minus 1. I'm going to call that equation 4. So clearly, g of x equals 1 in this case. Yeah? Put a full stop there. Let's just do that. So equation 4 is the general form of this type of equation in equation 3. So what we can do with this type of equation is attempt to trial a solution. So in other words, we're going to find by trial and error a solution to equation 3. So rather than just dwelling on equation 4 here, what we're going to do is we're just going to go straight to equation 3 again on the next page. So we've got dy by dx plus y squared plus 1 times, in brackets, xy minus 1. Now, we're told that's equal to 0, but for now, we're going to let the left-hand side equal this equation. So we've got to prove when this is equal to 0. So we need to prove when or for what value of y equation, what equation shall we call it? We'll call it, well, we've still got it as, we'll call it equation 5. We'll call this equation 5. So we need to prove when or for what value of y equation 5 is equal to 0. And why? Because if you go right back to equation 2, we're told that that equation is equal to 0 here, right? So, I don't know if this works in all cases, and it probably doesn't with some types of Riccati equations, but in this particular case, we can find a trial solution by just considering this part of the bracket. It might not always work, but it works for this. So what we're going to do is we're going to say what value of y, what value of y is xy minus 1 equal to 0, right? Well, it's quite simple. If you've done GCSE mathematics or any kind of high school mathematics, then you'll soon be able to ascertain that xy is equal to 1, meaning or implying that y is equal to 1 over x. Now, we still don't know if y equal to 1 over x here is a solution to the whole equation. We only know that it makes this part of the equation equal to 0. We want to know if it makes the whole equation equal to 0. So what do we do? Well, let's go on to the next page. We now need to show that y equals 1 over x is also a solution to the whole of, what do we call it, equation 5? Should go to the previous, yes, equation 5. So we've got, I'll just rewrite equation 5 again. So dy by dx plus y squared plus 1 times xy minus 1. Oh, and we're saying that the left-hand side is equal to that. So we've got to prove that the left-hand side, which is this, is equal to 0. But we can't write equal to 0 yet because we don't know. So we've got, I'll write this in blue. Since our trial, since our trial solution is y equal 1 over x, then the first derivative, because we need to know what this first derivative is in terms of x, if you like, then dy by dx is equal to minus 1 over x squared. I'll just quickly show you how to do that. So if y is equal to 1 over x, or if you like x to the minus 1, then dy by dx is equal to minus x to the minus 2, which is the same as minus 1 over x squared, right? So since our initial trial solution is y equals 1 over x, then dy by dx is equal to minus 1 over x squared. Right, let's go on to the next page. I'm going to write down equation 5 again. So the left-hand side is equal to dy by dx plus y squared. I'll dispense with the coefficient of 1, but I'll keep the bracket in there for you. just to so that it's not looking too different. So we know that y equals 1 over x and dy by dx is equal to minus 1 over x squared. So substituting y equals 1 over x and dy by dx equals minus 1 over x squared into what is now the right hand side of this equation, which we'll go back and call equation 5 because that hasn't really changed. We get I'll just write we get let's put left hand side is equal to minus 1 over x squared. I'll tell you what, let's just make that all a little bit neater. Doesn't look particularly great. So we get, on substitution of y and y prime, or dy by dx, we get the left hand side is equal to minus 1 over x squared. That's the dy by dx term here, plus y squared. Well, y is 1 over x, so it's just plus 1 over x all squared, plus we can take the brackets away because we've got plus signs here and here anyway, so it doesn't matter. So we've got plus x times y. Well, y is 1 over x, and then the minus 1 stays as it is. So the left hand side is equal to minus 1 over x squared plus 1 over x squared plus 1 minus 1, because the x times 1 over x just becomes 1. And as you can see, the 1x squared minus 1 over x squared, well, they just cancel because that's 0. And the 1 minus 1 is 0. So yes, the left-hand side is equal to 0. So I'll keep writing this in red. So since the left-hand side is equal to 0, then we know that y equals 1 over x. I don't know, formally, I don't know whether they call this a trivial solution or a simple solution. I would presume that it's a trivial solution, but I don't know. That's for you to go away and research and check out and learn for yourself. I'm just showing you the method of how to solve these. But do check everything that I do and go and do your own research, and double check that what I'm telling you is correct, because I do make errors. So since the left-hand side of equation 5 is equal to 0, then we know that y equals 1 over x is I'm going to put it in inverted commas, trivial solution. Right, so how does this help us find the general solution? Well, what we know is that this, oops, let's change to black. Right, there we are. This means that the general solution to, and let's just go back, right, the general solution to equation 3 let's just go back. This means that the general solution to equation 3, and we'll write it down again here, dy by dx plus y squared plus xy minus 1 equals 0 is of the form y equals 1 over x plus 1 over v. Right, you see that we take this initial trivial solution and add it on to the second solution that we're going to find. So how does this help us find the full general solution of this equation? Because we need to find v. Okay, so let's go to another page. dy by dx plus y squared plus xy minus 1 equals 0. And we know that a second solution, that actually should be, no, right, we know that the general solution, y, is equal to 1 over x plus 1 over v. Let me just double check that. Yeah. So if we differentiate, that was equation 3, wasn't it? Where did we get up to in terms of equations? 5, 6, right. So if we differentiate equation 6, we get dy by dx equals minus 1 over x squared minus 1 over v squared dv by dx. So you should know that from basic elementary differentiation and calculus, right? So substituting equation 6 and 7, so 6 and 7 into 3, we have, right, so we have minus 1 over x squared minus 1 over v squared dv by dx plus y squared, which is 1 over x plus 1 over v all squared, plus x times 1 over x plus 1 over v minus 1. It's a big 1 that. There we are. So that's equal to 0. Now, first of all, I'm going to multiply through by minus 1. Make that a plus, that a plus, that a minus, that a minus, and that a plus. Right, okay, let's go on to the next page. So what we've got now is 1 over x squared, I have to go back, plus 1 over v squared dv by dx minus 1 over x plus 1 over v squared. Previous, so that's minus x times 1 over x plus 1 over v minus 1 equals 0. Yeah, actually, I made a mistake earlier on, so it's only a very slight mistake, but let's just rub this out. That actually should be a -1, and let me see, what have I... No, that should be a plus. That should be a +1, shouldn't it? Yes. Okay. Well, let's see how we go with it anyway. So next, so that should be a +1. So if we simplify this expression, well, we've still got 1 over x squared there, plus 1 over v squared dv by dx, minus, and then we've got a big bracket here because we're expanding this. So we've got 1 over x squared, and then we've got 1 over x times 1 over v plus 1 over v times 1 over x. Well, that just comes out to be plus 2 over xv. And then we've got the 1 over v all squared. So we've got plus 1 over v squared. And then multiplying this out, we get minus 1 minus x over v plus 1 equals 0. Right, yes. So I can see it looks as though I think we are doing it right, but let's not jump any guns yet. So getting rid of this bracket by multiplying out by the minus 1 here, we've got 1 over x squared plus 1 over v squared dv by dx, minus 1 over x squared minus 2 over xv minus 1 over v squared minus 1 minus x over v plus 1 equals 0. Now then, straight away, to simplify this, we can see that cancels with that, and that cancels with that. So the 1 over x squared and the minus 1 over x squared disappear. They just cancel because one's negative, one's positive, and the 1 and the minus 1 both disappear because one of them is negative, the other is positive. So what are we left with? Well, we're left with 1 over v squared dv by dx minus, and I'm going to collect this term here and this term. So we've got minus and a bracket, and we've got 2 over x plus x with a v on the bottom there times 1 over v, and then this 1 over v squared term, which we will write over here. Okay, so in actual fact, we'll give that another label. So we got up to equation 7. So we'll now call this equation 8, right? So we can simplify equation 8 a little bit more. So we've got, if we multiplying equation 8 by v squared, we get previous, so we get dv by dx minus 2 over x plus x times v, and then v squared multiplied by minus 1 over v squared is just minus 1, and that's equal to 0. We call that equation 9. Now then, let me check my notes. Have I got the right equation? Yeah, so we can simplify it. One more very, very quick step to simplify this and get this in perhaps a slightly more manageable form. All we do is add 1 to both sides of 9 to get, I'm going to write this in green. It might be easy to immediately identify it. dv by dx minus, in brackets, 2 over x plus x v equals 1. We'll call that equation 10, in green this time. Now then, to solve equation 10, we use the integrating factor method. So to solve 10, use integrating factor method. Okay, so let's change color and go to a new page. So we've got dv by dx minus 2 over x plus x in brackets, of course. Let me just write that a little more clearly. Plus x equals 1. Okay. And also there wants to be a v there. Yeah, I think I've got it all there. So we're calling this equation 10. So for the integrating factor, E is, well, we find an integrating factor of the form E to the power of minus the integral of 2 over x plus x in brackets dx. And this might look complicated to solve, but all we actually have here is e to the minus e to the power of the negative integral of 2 over x dx plus, actually it's a minus the integral of x dx. So this exponential here simplifies to this exponential, where we've got e to the power of minus the integral of 2 over x dx minus the integral of x dx. Simplifying further, we've got e to the minus 2 over x dx times e to the minus integral of x dx, right? So now we can deal with these separately. So what we've got is the integrating factor is equal to e to the minus 2 log x times e to the minus x squared over 2. That is not at all clear. Let's just rub it all out. There we are. X squared over 2. Right, okay, so this simplifies further to give e to the log of x to the minus 2 times e to the minus x squared over 2. And of course, e to the log of x minus 2, as you might know from previous videos that I've done, e to the power of a log of a number just gives that number. So in this case, what we have here is x to the minus 2 times e to the minus x squared over 2. And this is our integrating factor. Therefore, multiplying multiplying equation 10 by the integrating factor, we get x to the minus 2 e to the minus x squared over 2 times dv by dx minus x to the minus 2 e to the minus x squared over 2 times 2 over x plus x v equals x to the minus 2, because we're multiplying both sides of equation 10 by the integrating factor of x to the minus 2 e to the minus x squared over 2. Right, okay, so we'll call that equation 11. Whoops. Right off the edge of the board there, 11. Right, so we need to simplify this on the left-hand side. And if you have done A-level calculus with a substantial portion of ordinary differential equations, in particularly first order differential equations, then you will know how to simplify the left-hand side. So simplifying let me just right, simplifying what equation do we call it? Equation 11. Simplifying equation 11, we can write equation 11 as d by dx of, I'll put square brackets in, so let's just go back to it. Well, we know we've got to write down this x to the minus 2 times e to the minus x squared over 2. So let's do that. X to the minus 2 e to the minus x squared over 2. And then we've got to write something else down from this, this second term in the ordinary differential equation. And all we have to worry about is v, and that's what we're writing down. So if we write v down there, we can now put that equal to x to the minus 2 times e to the minus x squared over 2. So we've got e to the x minus 2 e, sorry, did I say that right? We've got the left hand side here equal to x to the minus 2 e to the minus x squared over 2. And of course we want to integrate this. So integrating well, actually, at this point, we have to pause for a moment because, well, first of all, we integrate both sides of what we will call equation 12. So the d by dx on the left-hand side disappears, and all we're left with is x to the minus 2 e to the minus x squared over 2 v, and that's equal to the integral of x to the minus 2 e to the minus x squared over 2 dx. Right, now let me just write that more clearly. Now this term on the right hand side is not trivial to integrate. In fact, what I did was, instead of doing yet more reams of mathematics, I simply reverted to a mathematical package, a mathematical computer package, of which one can use Maple, Mathematica, Python. Python is a good free one that you can use, and that should help you to solve this integral on the right hand side. And so I'm actually just going to write down the integral on the right hand side of this equation. So what we get is, we'll just put our implication sign. So what we get is x to the minus 2 e to the minus x squared over 2 times v equal to well, we've got a minus e. Let's write this consistently. Let's be consistent with this. So we've got a minus x, not an x squared, but a minus x, according to my notes here. Minus x squared over 2 minus the square root of the whole of pi over 2 times the error function. Now, I've written here in my notes error function. Do check this because I make mistakes even in my own separate private notes. Do check that that's not an imaginary error function or a complementary error function. I've got ERF here. That implies that it's an error function, but I could have made a mistake. But without looking in depth now, I can't verify that. But that'll be a bit of homework for you to work out whether I've written down the correct terms here, ERF. And in the bracket there, we've got x over the square root of 2, right? Plus a constant of integration. And I'll just separate that from that. So that's what we now have. So we're nearly there. We're nearly finished, but not quite. Maybe another couple of slides to go. So what we can do is we can divide both sides of this equation. I'll give it a name. We'll call this equation 13. So dividing both sides of equation 13 by x to the minus 2, e to the minus x squared over 2, we get v equals minus x squared e to the x squared over 2 times the square root of the whole of pi over 2 multiplied by, I'm taking this to be the error function, assuming I haven't made any mistakes, and that's x over the root of 2 plus k x squared e to the minus x squared over 2. Right? Now, we know that our general solution is equal to y, which is equal to 1 over x plus 1 over v. And before I write down what I've got in my notes, I'm going to see if there's a simpler way of writing it, and yes, there is. So we know from, so that's equation 13, this is equation 14, and since we know that the general solution y is equal to 1 over x plus 1 over v, where v is equal to, let's outline it in red, where v is equal to all of this, then y is equal to 1 over x plus 1 over, and I'm going to write this positive term first. So we've got kx squared e to the x squared over 2, right? It's not very plain, is it? So let's do it a little more boldly. So we've got kx squared e to the x squared over 2 minus x minus x squared e to the x squared over 2 times the square root of pi over 2 times the error function, again assuming that I've written down the error function correctly, assuming it isn't the imaginary or error function or the complementary error function, then that final term there is x over root 2. And that is the general solution to the original equation. Okay? This is a general solution. Y equals 1 over x plus 1 over all of this, which I'm not going to repeat verbally. But I hope that's helped you, for those of you who are looking for solutions to this type of equation. And I hope that you will come back in due course to look at not only previous videos of mine, but current and future videos, and tune in for more mathematical exploits. So thank you very much for watching, and see you soon. Goodbye.